we'll start our class with this, and other persons, if they want to join, they can join in the middle. So see, yesterday we studied about the tropical cyclones. So how those cyclones taking places when it is near the tropical area. So all those parts we studied. Now today we'll see about the temperate cyclone, and in this temperate cyclone we'll be seeing about the, say, in tropical cyclone, Coriolis force is important, then temperature, pressure is important. So the same thing in the temperate cyclone also, the same thing important, but only thing is that in temperate cyclone, in that tropical cyclone where it is happening mostly in the water bodies. But whereas temperate cyclone will occur on the land surface also. Now why it will occur on land surface? Because temperate cyclone happens because of the formation of front, and you all know that front happens on the land also and near the water bodies also. So temperate cyclone will occur on the both places, on the water surface also and also on the land surface. So all those process we'll see. Yesterday we saw about the temperate cyclone, and we saw about the eye wall, all those things we saw. Okay, and you also must remember all those different names of temperate cyclones. And then we saw that why Arabian Sea has the less number of cyclones, whereas the Bay of Bengal area has more number of cyclones. That was that. And then after that we saw that how does the naming of cyclone happens. So that naming of cyclone, how it is happening? All those countries located near the, sea area in the Indian Ocean. So there what happening? They are arranged according to their alphabetical order, and all countries, they will give, each country will give 13 names. So in that 13 names, if they would have like in arranged way they will give. So in that way, arrangement matter. In that way, if cyclone comes, then first name will be given by the Bangladesh. Then after it again, if cyclone comes in the Indian Ocean, then the Indian name, that Gati, will be given. Then next Iran name will be given. So if this column gets finished, if this row gets finished, then we'll move to the next row. Then next, now see, recently we had the Biparjoy. Then after that, if cyclone comes finished, the next name will be given the India, that is Tej. So in this way naming happens. So this part also we saw yesterday. Now see, yesterday we did not say about the warning system. So see, in this warning system, we have 4 stages. So in that 4 stages, we have one pre-cyclone watch. So pre-cyclone watch means what? If cyclone is going to occur in the Pacific area, Pacific region, or in the Indian Ocean also. So there what will happening? They'll give us the warning. All the department, they'll give us a warning. Means when they'll give the warning, that is issued when a depression forms over the Bay of Bengal. So that is distance from the coast. So that is issued before 72 hours in the advance. Okay, that is pre-cyclone watch. So in that case, what happens? Cyclone might also come and might not also come. So that 72 hours, if there is some formation of depressions in those Indian Ocean area, then before the 72 hours, they'll give the advance warning. Then this is the first step. Then next step is, see, now this color, all this cyclone alert. See, first about this one, for pre-cyclone watch, they have not given any color or anything. Okay, simply they'll announce. So that is before 72 hours. Means the gap should be there at least 72 hours. And after that, see, we should know about the colors. We have green color. So green color means what? Green color means no cyclone will be coming. Suppose if they have given the warning, that is pre-cyclone watch, that warning they have given, and if no cyclones are coming, then they will give the green color. And yellow color means what? Here yellow color means what? We have the 48 hours. So that before 48 hours, they'll give this warning. If yellow color warning they give is 48 hours. Then after that, orange color means it is 24 hours. That means it is going to approach. Then red color means it will be approaching. That is 12 hours. So all those color warnings part we'll see. In this green color, you must remember that if no cyclone is coming, there is a less chance of cyclone occurring. Then green color will be shown. Then in this cyclone alert, now we'll see about the color code yellow. So in this yellow means what? That is issued at least 48 hours before the commencement of the bad weather. So if there is a bad weather in the Indian Ocean area, so that means what? Before 48 hours. Means 48 hours gap will be there. At least before the 48 hours, they'll give the warning. So that warning is yellow color code. That is indicated by the yellow color. Okay. And that cyclone will be beyond 500 kilometers from the coast. Okay. When it will beyond the 500 kilometers from the coast, that time means beyond the 500 kilometers, and also that before 48 hours will give the warning. So they'll show the yellow color. So that is yellow color code for the cyclone alert. Then what? Before the 48 hours they'll give that warning. Then in that what will happen? After each 3 hours. After each 3 hours from there, they'll start giving the warning. If cyclone occurrence is going to happen, then what they'll do? When they have given the yellow color code, when they have shown the yellow color code, then after that, yellow color code means what? Before 48 hours, they have given the yellow color code. Okay. Now, after that, when they have shown from there each 3 hours, every 3 hours, they will be showing the yellow color code. So remember that. That means cyclone alert is there. So cyclone is going to come. Then next is cyclone warning, that is orange color. So in that orange color, what they will do? In the orange color, they will give us warning before the 24 hours. So before the 24 hours means what? It is confirmed that cyclone is going to come. So there what? We'll start shifting all those shops and everything. So they will start shifting. So that means orange color they have shown. So that is before 24 hours. And say before 48 hours means what? All those settlements near the coastal area, they will start shifting towards the other places. Okay. So orange color, so before 24 hours, and that will be within the 500 kilometers. So yellow color we saw that will be if cyclone alert is there after 500 kilometers. Okay. Means it is beyond the 500 kilometers. And in yellow color it will be given before 48 hours gap. Means at least 48 hours gap should be there. Where in the orange color at least 24 hours gap should be there, and that will be when the cyclone is located within the 500 kilometers from the coast. Means within 500 kilometers. In the orange color we had beyond 500 kilometers. But whereas in this orange color code we have the within 500 kilometers from the coast. Then next is the red color. So red color you all know, you can see the traffic also. So red means what? There is some dangers. So that is issued before the 12 hours. Okay. When the cyclone is going to fall, before the 12 hours, it is given. Then after that means what? When the cyclone, in that case, cyclone will be within 200 kilometers. And you know that cyclone will be having a heavy wind speed will be high. So it might come to the land area at any time. So before 12 hours, they will give this warning. So these are the warning systems. So you must remember all those codes. So all those codes you must remember. Now we will come to the temperate cyclone part. So this was all about the warning systems, and yesterday we saw about all those other parts of tropical cyclone. Now we will come to the temperate cyclone. See, temperate cyclone means what? You all know that where we have the temperate region. See, this is our Earth. Here is our equator. Till 30 degree north and till 30 degree south, we have the occurrence of tropical. We have the occurrence of tropical cyclone. Okay. Then after what happens? Now here we have the 35. After this 35, then again here we have 60 degree north and 65 degree north. And here we have the polar area. So from here we have the high pressure coming. Here we have the low pressure. Again from here we have the high pressure. Okay. So these are the temperate regions. So from here to here, these are temperate region. So it is between the 35 degree to 65 degree north or 35 degree to 65 degree south. So in those both places, if cyclone occurs, that is known as the temperate cyclone. And temperate cyclone are known by the various names. So they are known as the mid-latitude cyclones, extratropical cyclones, frontal cyclones, or you can say it as a wave cyclone. And why it is known as the frontal cyclones? front. See, all those parts will be understanding. But why it is known as frontal cyclones? See, we studied here. We studied while we were studying about the fronts. We studied that in these parts. See, from here, warm air is blowing. Okay, from here, what is happening? Cold air is coming. So in this case, what is in northern hemisphere? We have the rightward deflection. So towards this side deflection here, and from this place we have towards this side. So here what is happening? Cold air will be subducting and this warm one will be ascending. So in that case, what will happen? A sloping boundary type will take place. Okay, and that sloping boundary is the front. So in this, what happens? Front, due to front only, because see, now when the front formation will happen, now this warm air will go up, and that is with the moisture, because see, from here what is happening? Cold air is coming. So that with the moisture, when it is going up, in frontal cyclone, we say that there is a formation of clouds. Okay, so when it is going off, it is carrying all those moistures. So there is a formation of clouds in the upper parts. Okay, then after that they will be like going to the large size, and after that when they fall down on the earth as a rainfall, so that occurrence will be known as the temperate cyclones. So see here, in this temperate cyclone, you can see through this diagram also that between 35 degree to 65 degree we have the temperate region. So all those cyclones happening in these regions. So we know that we have the temperate cyclone, and you know why it is known as why it has the occurrence on the land also, because see, tropical cyclone formation happens only in the water bodies. Okay, whereas temperate cyclone occurs both on the land and also on the water bodies. Okay, why? Because see, front temperate cyclone is also known as the front cyclone, and we have the front formation on both water and the land area. When we are studying about the front, there we saw, or even in the east side, we have the front formation area. So because of that front formation area, when it is warm air going up, it is forming into clouds and it's raining. And there in the front cyclone, important that front is there, what is known as the occulted front. So in this temperate cyclone, mostly the temperate cyclone happens due to the occulted front. Okay, so we studied that in occulted front we have the formation of clouds also. We studied. Like means what? From here, cold air descending, warm air is going up. So in this case, what is happening? Warm air will go up, cold air will come down. So in this case, what will happen? Cold air will settle down here, and this warm air will go up, and it will deflect. It won't cross tropopause, so it will deflect. Now in this case, when that deflection will happen, so there is a formation of clouds. So when the formation of clouds will be there, so there what will happen? If they are not able to suspend themselves, so due to gravitational pull, they will start raining. So when the raining happens with high speed of wind, that particular cyclone known as the temperate cyclone. Okay, and this also can be explained through the polar front theory. Polar front theory is what? From the polar area we have the cold air coming down, and warm air mass from this tropical part it is going up. So this also known as the polar front theory. In temperate cyclone, polar front theory is used, occulted front is used, and this temperate cyclone occurs on both on the land and also on the water bodies. So remember this part. Okay, see here. By through this diagram you all can understand. See, now in this diagram, if you draw this equator, we have the 0 degree, then we have 30, 60, and then this north pole. So here what happening? We have the temperate cyclone from this part only. Okay, this part only we have temperate cyclone. So here what is happening? Cold air is coming down, warm air is going up. So warm air, when it is going up, so there is a formation of front, and cold air will occupy all these places. Okay, and what happens when the cold air fully occupy these places, and after that what will happen? This warm front also, after that formation of clouds, that will be like, it will form like a stationary. There will be no contact. So when it forms those fronts like, then there will be the dying of the cyclones. Okay, there will be dying of cyclones. So this is about the temperate cyclones. So see here, development of cycles, a stationary phase, then young adult phase, then mature phase. Then due to occulted front, we have all those raining, and at last we have the dissipation. So dissipation is what? dying of the cyclones. So that is about the cyclones. You just know the all those stages. Okay. Whether slides are changing or not, anyone confirm me whether slides are changing or not?
No, sir. Slides are not changing, sir.
Then you should have an interface me in the middle. Just I was going in the flow. Okay, now?
No, sir.
No, sir.
Now, can you see the development of cyclone?
Yes, sir. It's
Okay.
in the warm air glide, sir.
Okay, okay. Okay, so see here, you all understood that temperate cyclone happens in the this part, where we have the like 30 degree, that high pressure, low pressure area, where we have that area, that 30 degree, 35 degree north to 65 degree north. So in these area, temperate cyclone occurs. So in this, why it occurs? Because of the front formation on the land area. Okay. So because of accumulated front formation, we have the temperate cyclone in this area. What will be happening from this part, from the pole part, cold air will be coming, and from this part, from the subtropical part, high pressure warm air will be going. So in this way, this cold air, what they will do, they will occupy all these down places, and this cold formation, when the front formation happens, then it will be going upwards, and there is the formation of clouds. So in this way, the formation of temperate cyclone takes place. Now, development of cyclones, that how it is happening. So first we have the stationary, or that you can say the beginning phase. Then we have the young phase, then mature phase. Then due to the accumulated front, we have the rainfall. There only the main cyclone formation happens. Then at last, when the cyclone dies, when the accumulated front becomes the stationary front, so that time the cyclone dies. So that process known as the dissipation. Okay. Now in this, see, the warm air glides over the cold air. So that's what we saw, that warm air will ascend, and a sequence of clouds appear over the sky ahead of the warm front and cause precipitation. So the cold front opposes the warm air from behind and pushes the warm air. So in that case, what happens? Cumulus clouds will develop along the cold front. And when that cumulus cloud formation happens, so there will be the formation of clouds on the upper part, and after it we have the rainfall. So that leads to a well-developed extratropical cyclone. So temperate cyclone is also known as an extratropical cyclone, and also we saw in the previous slide that is also known as the mid-latitude cyclones, or you can call it the frontal cyclones, or also you can call it the wave cyclones. The cold front, what happens? They move faster than the warm front. Okay. Then that will overtake the warm front. Then that warm air, what will happen? That will be completely uplifted. When it is completely uplifted, that time we have the front formation. So that front formation is known as the frontolysis. Okay. Then after the temperate cyclone is intense and frontogenesis is involved in the occlusion type of trends. So when that dying happens, so after the formation of front, so we have the occluded front formation. So when the rainfall, all those happens, when that occluded front becomes the stationary front, so that time dying happens. Okay. So remember this occluded front name. So this you can see distribution of temperate cyclone. You can see in the US and Canada area. Here we have the most time. We have the temperate cyclone, and see this temperate cyclone is influenced by the westerlies and also the easterlies. See, now from this part we have this is equator, then this is 35 degree, this is 65 degree. So here we have the trade wind blowing. Okay, in this part we have the westerlies, and in this upper part we have the easterlies. So in this way, what happens in this easterly, but because of easterly wind, what happens? Easterly wind means what? That cold wind, that will be in the high speed. So that will blow up through the many parts. So even that rain will happen in this part also, even in Canada area also, and also enter into the Europe area. So here we have all those Greenland area. Here we have the Russia area. So in these all parts we have the temperate cyclones. So see here. Now in USA, Canada we have, then Eastern Canada, Rockies, Lake region. Then also it will go to over the Russia and Siberia area. Okay. Now even in the Baltic Sea also happens. So winter storms we have in the Baltic Sea during the temperate cyclone. Then Mediterranean basin, that is extending up to the Russia. So that event to India in winters, what happens? That because of this temperate cyclone only, we have the western disturbance in India. So western disturbance in India, see, from where this wind is blowing, so it is coming to this part, and this part when it is coming, what is happening? Here we have the Himalayan. So here what is happening? During the winter we have the rainfall in the northern India. So that is the western disturbance. So because of temperate cyclone, we have the western disturbance. Okay. Now all those characteristics are given. So that temperate cyclone are asymmetrical and it will shape like a V. So how V formation will happen? You can see in this previous diagram. See here. In this diagram, see now what will happen? Cold air will be just blowing up the warm wind. So warm wind will be ascending. And in that case, V-shape formation happens. So remember that in occluded front, V-shape formation happens. Okay. So now in the temperate cyclone, we have the formation of front, that is occluded front, and we all know that occluded front forms the V-shape. So what happens in the temperate cyclone also? We have the V-shaped cyclone formation. So that is inverted V type. Okay, and they will spread over like 2,500 kilometers over the North America, and they have the height of 8 to 11 kilometers. That is in the troposphere part. So now see, now difference between the temperate cyclone and tropical cyclones are mentioned in this. So see here, origin. So origin, the tropical cyclone is occurring because of thermal origin. Why thermal origin is what? When we have the insulation part. So when we have the insulation part, so because of that only water is heating. So and all that is becoming the low pressure, and from all other sides we have the high pressure. So because of that only we have the front formation that is going up. So that is tropical cyclone formation happens because of thermal origin, whereas the temperate cyclone is dynamic origin. Means what? In this Coriolis force is there, then that Coriolis force, then earth movement is there, and then also air masses. So because of air mass, we have the formation of front. So in this origin is from the front also and Coriolis force also. And in this also we have the Coriolis force, but mainly the thermal origin. Okay. Then you all know that tropical cyclone will be between the 10 to 30 degree north and south, and where the temperate cyclone will be 35 degree to 65 degree north and south. Okay, and that will be mostly in the sea. This temperate cyclone mostly it will be taking in the northern hemisphere. Why northern hemisphere? Because in northern hemisphere we have all those land parts and also the water parts. So there only all those front formation will be happening in northern hemisphere only. Whereas if you go in the southern hemisphere, so in the southern hemisphere what happens? We have the Antarctica, and you all know that Antarctica is filled with all those ice caps, glacier. So here in this we don't have any settlements or land area. So here we won't have the front formation. So mostly that temperate cyclone will be happening in the northern hemisphere. Okay, and that is due to the greater temperature contrast. Then frontal system, you all know that in tropical cyclone it is absent, and whereas in this temperate cyclone it is present. So that means occluded front is happening there. Okay, then formation. So they form only on seas. Okay, and also temperature should be above 26 or 27 degrees Celsius. But here it can form both on land as well as the seas. Okay, then next differentiation we'll see. Then season we have the late summers. In this it is irregular, so it might come anytime. Okay, so only little few will be there in the summer, and it will be more often happening in the winter season time. Then size, you all know that this one temperate cyclone occurs up to like 2,000 kilometers, and here this tropical cyclone it will be occurring only like 500 kilometers only, not that much. So here we have the variation in the strength of cyclone. Okay, and here what it will happen, it will be varying from region to region. And tropical cyclone, you all study that it will move in a cyclic manner, so that elliptical orbit type formation is there. Whereas in temperate cyclone we have the inverted V. Okay, and then rainfall, what will happen? We have the heavy rainfall, but you all know that when the cumulonimbus cloud formation is happening, so it will have the heavy rainfall. But what will happen? That will not last for more hours. Like within some hours it will die. Whereas in the temperate cyclone, what happens? It is slow and it will continue for many days. Let's see wind and velocity we saw. Here we have the 100 to 50 km per hour, and the upper troposphere where it is goes, it is 200 to 1200 km per hour. Where in this wind velocity is very less, it has the range of 30 to 150 km per hour. Okay, so in this case, in the temperate cyclone, we have the less destruction. Okay, whereas in this, due to the high speed of wind, we have the greater destruction. And isobar means you all know that lines joining the equal pressures, the same pressure gradient. Okay, that is the isobar. So here what is happening? Complete circles and the pressure gradient is steep. So you all know that when we have due to the high pressure occurrence on the fully on the low pressure side. So here what will happen? That warm air must be go steepwards. Okay, because of high pressure coming from all directions. So we have the steep type formation. Okay, then lifetime. So it will last for a week. Okay, where this temperate cyclone it will go for the many more times. Means where the formation of inverted will taking place, there temperate cyclone will be happening. So it lasts for the many days. It is not for that only a week. It lasts for many days. So because of that only we have the winter rainfall in the northern hemisphere. Then paths, that is east to west, where in this temperate cyclone we have the west to east. Okay, so in this we have the westerlies and jet stream, and here in this if jet stream comes with this tropical cyclone will die. So and temperature distribution, that is equally distributed. That means if sea area means that all those ocean parts. So you all know that at that particular part where they are having the maximum incoming solar radiation, so there a case of low pressure will be there, and all of the surrounding parts will have the maximum equally distributed all those temperatures. Okay, and here what will happen? They will all the sectors, all those regions, they will have the different temperatures. Then calm region. So here what will happen? The center of the tropical cyclone, that eye will be calm. Okay, and in that eye there will be no rainfall. In a temperate cyclone, there is not a single place where winds and rains are inactive. It will be raining everywhere. Okay. Then here driving force are latent heat of condensation. Okay. That and vaporization also there. That where we have the heat loss. Okay. And in this we have the temperature, humidity, and density differences of air masses. Then jet stream, if jet stream comes in this area, then what will happen? It will die. So relationship between tropical cyclones and the upper level air flow is not very clear. Where in this temperate cyclone we have the relationship with that all those jet stream and also the westerlies. Then cloud formation. So in this part we have the cumulonimbus, nimbus, etc. And in the temperate cyclone we have the various clouds formation with there. Okay. So various type of cloud development is there. And here what will happen? The tropical cyclones are not associated with the surface anticyclones. Means here in this case what will happen? That once it reaches the surface, see if tropical cyclone comes on the near the land area, if rain happens, so what will happen? On the land it will die. Okay, so they don't have the anticyclone. But when this temperate cyclone, again when the reaches is the end, then again from there again it will come back. So in that way it takes place. So here we have the anticyclone, whereas in this place we don't have the anticyclones. Then influence on India, what will happen? In this both coasts are affected. Okay. And here in this we have the western disturbance in the temperate cyclone. And weather prediction tough as the movement can be erratic due to a lot of factors. And here it will have what will mean slowly rain will be happening. So here we won't have that much destruction. Okay. So in this temperate cyclone, we won't have that much disruption. So that was about the difference between the temperate cyclone and tropical cyclone. Now in this, we'll also see one more part, that is the polar vortex. So what is that polar vortex? So polar vortex is when the temperate cyclone occurrence is happening. So in that case, what will happen? See, downwards we have the high pressure. When after the temperate cyclone occurrence happen, when it dies. So here down we have the cold air formation. Okay, all those cold air will settle in this part, and all those warm air will be in the upper part. So in this part we have the high pressure. Okay, and here we have the low pressure. So this formation of this pressure gradient force. So this is known as the polar vortex. So polar vortex is a polar cyclone. Arctic or polar cyclones can occur in the polar regions. So it will occur in the polar region, and they can occur at any time of the year. So that will occur in the polar area at any time. You can see polar vortex is a upper level low pressure, upper level low pressure. So system that low pressure is at low pressure we have the upper part, and high pressure we have the down part. So that is the polar vortex. You can see here in this diagram. After when the formation happens, when the temperate cyclone dies, see here. Here we have the cold air mass will occupy all these places, and in the upper part we have the warm air. So there is the formation of low pressure in upper part and high pressure in the down part. So that was about the polar vortex. Okay. Now all this was about the temperate cyclone and tropical cyclone, and also the polar vortex. So you all must remember that what type of clouds formation are happening. And also we saw about the arrangement of clouds. I said you that is important because that is important for arranging the clouds, and already that question has come. So remember that one. Okay, that first we have the nimbostratus, then we have the altostratus, then we have the cirrostratus, then we have the cirrus. So remember the arrangement of all those patterns. So that was all about the temperate cyclone and tropical cyclone, and with that we have finished the climatology part. So now we will start with the oceanography part. So that was all those from the climatology part, and if any doubt from those parts you can ask me later on the WhatsApp. And now we will start our class with the oceanography. So can anyone confirm me that whether these oceanography slides are visible to you all or not? So can you all see the oceanography slides?
First page, sir.
Okay. Okay, still now we are in the first page. Okay, can you see this second page, that ocean relief features, that major ocean relief features and minor ocean relief features?
No, sir.
Okay. Now can you see the next page, ocean and seas of the world?
Yes, sir.
Okay. Okay, thank you. So now we will start with the oceanography. See, in this oceanography part, only some parts are important. So in these some parts, which are the parts important? In this part, we should know about, see, in the oceanography part only, we will be studying about the La Nina and El Nino. Okay, so this part is important. Then ocean current part is important. Then we have the next part, we have the relief features. Oceans are important. So all these three parts are most important. Okay, so all those syllabus what we are going to study in the oceanography, all those parts are mentioned in this slide. So see it. As we enter into oceanography, so ocean is what? There when we go to the oceans, already when we are studying about the sea floor spreading theory. So there we studied that when during the World War II, when Harry Weiss and the captain, Indian Navy captain, when they wanted to attack the enemy from the water bodies part. Okay, so what they had done, they went down with the submarine, and there they found those different features, landform features on the ocean surface. Okay, different landform features. So because of that, after that only they were able to conclude the theory of sea floor spreading theory, and there they gave that formation of relief features in the ocean parts also. So that was all about the oceanography, and in that part what will happen, we will see that in ocean parts, because of oceans we are getting all those marines, foods and everything. So in the ocean, in the sea part, we get food from the sea, and climate and weather appearances changes that occurrence are also happening to the oceans. Okay, then from the oceans we have the transportation, fishing, navigation. So transportation is what, like large heavy masses of products, all those are supplied from one countries to another countries. Okay, then because of oceans only we have flood, rainfall and drought. Means flood, rainfall, how you can understand that? When, see, in India, when we have the La Nina years, so during the La Nina years we have the heavy amount of rainfall. Okay, so in that what will happen, you might have the flood also. Whereas in this El Nino part, in this part, that monsoon time season will be dry. So in this case, what will happen? We have the rainfall. Then because of that, we have the drought. So in this way, oceans affects the climatic part also. So in this, we'll study about different parts. So in the first part, we'll study about the relief features. So first we'll study about the relief features. Then next we'll study about the oceans and seas of the world, and also we'll study about the ocean waves, tides, all those parts we'll study. Then we'll study about the ocean currents. Then salinity also we'll study. Then vertical and horizontal temperature distribution of oceans. Coral reefs we'll study. Then El Nino, La Nina, all these parts we'll study. Then this is unclosed. See, for ocean conservation, we have the unclosed. Okay, so that also we'll study about this part. United Nations Convention on the Oceans and Sea. Then we have the oceanic pollutions. So that oceanic pollution is not that much important. Okay. Then in the 13th part, we'll study about the marine resources. So marine resources, you can easily understand in this part. It is not that much important. From this part, never questions have been asked, but for knowledge purpose, you must know. And we don't know about the UPSC. They might ask questions from anywhere. So we'll see all those parts, and these are all the easiest part. Okay. Only some important parts is that current part you all must know. Then La Nina, El Nino, and then the relief features part you all must know. So see it. Now we'll move to the first. We'll study about the ocean relief features. So in this ocean relief features, while we were studying about all those plate convergence, plate divergence, all those parts we were studying. So see here in this part, ocean relief features. That ocean relief features are divided into two parts. Okay, one is major and another one is the minor parts. See here, one is major and one is minor parts. So before that, first we'll see the introduction of the oceanography. So in the ocean reliefs, so that is really largely due to the tectonic, volcanic, erosional and deposition process. So in that, all we saw the formation of landforms and everything, and because of tectonic, plates, divergence and convergence, we have the formation of trench, all those parts. So we saw in that earlier classes. So in this, ocean relief controls the motion of seawater. The oceanic movement in the form of ocean currents in turn causes many variations in both the oceans and the atmosphere. That movement will be there, means many variation will be there. Okay. Then that for navigation and fishing, all those reefs are important. So all those we'll see that whether at which place we have the fishing that is possible in the large masses. So that all those we'll see. Now see. So in this ocean reliefs, first we'll see about this. We have the we have named all those relief features in two different parts. One is major relief features and one is minor relief features. Okay. In the major reliefs, we have the continental shelves, continental slope, continental rise, and the deep sea plains. Okay. And in the minors, we have mentioned canyons, trenches, mid-oceanic ridges, atolls, coral reef, that is coral reef also you can say, or coral reef. Then we have gyres and sea mounts. So all these minor relief features are parts of the deep sea plain. Okay, deep sea plain or abyssal plain. So these are the minor relief features, and this shelf, slope, rise, all these are the major relief features. So now see, in this previous part, see in this see how all those formation of mid-oceanic ridges are happening. We saw when the divergence between the plate boundary is happening. So what is happening when the divergence is happening? So they are going. So from here we have the basic lava flowing upwards. So when the basic lava is flowing, there we have that first it is sitting down here. Then again this place is going this side. Then again we have the new formation here. So in this way, ridges formation is happening. Okay. So now in this part, see here. Suppose if this is our Indian country. Okay. Now in this case, we have the water body here. This is the water body. Okay. Now in this case, what is happening? All those see, we have the ocean formation, and how the ocean formation took place. You all know that in ancient era, that Panthalassa, first our Pangaea divided in two parts. We have the formation of Tethys Sea, and also before itself we have the Panthalassa, and that also because divided of all those plates, we have the divided the ocean part also. That Panthalassa also got divided into many parts. So we have given the name that all those oceans, Atlantic Ocean, Pacific Ocean, Pacific we have given, Atlantic Oceans we have given, then Indian Ocean we have given, then we have given the Southern Ocean, okay, that also you can say it as the Antarctica Ocean. Then we have the Arctic Ocean. So all those 5 oceans we have. So now in these all those oceans part, we have the mostly the same type of landform features. Okay, so all those features are named by the different names. So see here. Now what is happening? This is our Earth part. Okay, so from here what is happening? Now this part is going down. Then again here lies. Okay, so now see in this part. So in this part which is jointed to the land part. Okay, what would happen? See, due to the sea rise, due to the that water rise level, or you can say the sea rise, or you can say when the land what is happening, that land submergence is happening. So when the land submergence is happening or the sea rise is happening, means what is happening at this part also water will come. First water will be there in this part, all those depressions part. Okay, now what happened due to the sea rise, all those level rise of water or the submergence of the plates. So here what is happening? Here also we have the water bodies. Okay, now this part, water bodies part is known as the continental shelf. Okay, continental shelf. Why it is known as the continental shelf? Because it is a part of continent part only, and it is a flat part in the upper, that is jointed to the land part. Okay, so here we have the continental shelf. Then as we go down, then there will be a break. Okay, there will be a break. So this is known as the continental break, and after it we have the sloping area. Then that sloping area is known as the continental slope. This part is known as the sloping area, is known as the continental slope. Okay, and this is the break, where that after the continental shelf part finish and continental the sloping area starts. Okay, that is the continental slope. And this part what happens? See, now in all these areas, that from the land, all those land forms, we have the water bodies coming and mixing into the ocean part. We have the water body coming and mixing the ocean part. So what will happening? They will bring sediments, or also the when we have the wave formation, we have the swash and backwash. So with that, when it will go to land parts, from there erosion happens and it brings them down the materials. So all those materials, what happens? All those materials settling down after the continental slope in this area, they are settling down. Okay, like a flat area also you can say, and that looks like a rise part. Okay, so after the continental slope, that all those depleted materials that is seen, that looks like a rise part. So that part is known as the continental rise. Okay, so that part is known as the continental rise. And remember this order also from the land part. First we have the continental shelf, then we have the break, then we have the slope, and then we have the deposited part, that is known as the continental rise. And after that, when as we go downwards, after that all those relief features in these parts, that is known as the deep sea plain, or you can say it as the abyssal plain. Okay, so you can say the deep sea plain and or abyssal plain. Now in these deep sea plains, we have the formation of many different types of relief features. Okay, before seeing all the deep sea plains features, we will also see about the trenches part. See here, we studied that when we have the two plate convergence, either oceanic or oceanic continent pair. Okay, so in that what will happen? That one, that denser part will be going down and the upper part. So here one in that upper part, that here we will have the volcanic eruption. So here in this part what will happen? Here we have the formation of trenches lines, and the oceanic part also. When the oceanic also they collide with each other, then here we have the formation of trench. So formation of trench means what? That will be deep part. It will be like a narrow part. So that is the trench part. Okay, trench. Okay, all those definitions or everything I'm mentioning aside. So that is the trench part. Okay, now see about the deep sea plain. So in this deep sea plain, we have various types of landforms in all those oceanic deep area. So in those various parts, see, if this is the deep sea plain, so in this area what is happening, when we have the occurrence of volcanoes inside the oceans. So inside the ocean is what will happen? We have the formation of mid-oceanic ridges. Okay, mid-oceanic ridges. Here, when the volcanic eruption is happening, so what is happening? Now this part is getting settled down here, and you know that in what when the oceanic plate collides, so there we have the basaltic lava formation. Okay, in that case, what will happen? They will come in a liquid part, so they will flow to the longer distance part, like this point deep part in the deep sea, in the deep ocean part. When with the point like part, that is known the sea mount. In this example, you can see it. That is known the sea mount. Okay, that will be not coming to the up of the water. It will be below water only. Okay, and when we have the point tip part here, that is a sea mount. And if we have that landform formation, and it will be smaller than sea mount. Okay, and that will be like, it will be looking like, when we have little, you can say it like this, it is going, and little you can say here, this is little bit flat based. So that flat based part is known as the gyots. Okay, this part is known as the gyots, and this point tip part is known as the sea mount. So remember this important that words, that point tip means sea mounts, and we have flat surface means what? Gyots, and this flat space, this will be smaller than the sea mounts. And if that volcanic is coming out of the water, so what will happen? Now here what will happen? Formation of island will happen. So that particular part is known as the volcanic island. Okay, so that is about the all those deep sea plains. So in the deep sea we have the sea mounts, gyots, we have mid-oceanic ridges. So all these are the deep sea plains part. And all these continental shelves, continental rise, slope, all these are parts of the minor relief features. All you can say, all these are parts of the gyots, canyons. All these are parts of canyons. You all are studying the landform formation. There we study, and atolls and coral reefs we'll see in the later slides. So these are all the minor relief features. And all these continental, all those are related to the nearby the continental part and the deep sea plains. So these are the major relief features. So see, here all those definitions we have given. So this is the continental shelf is the seaward extension of the continent, and they have a gentle slope. Means slope that angle will be like less than 1 degree. Somewhere it will be written that 1 degree to 3 degree. So mostly it will be less than that 1 degree. Okay. So there we have, and there we have the shallow water. In continental shelf, this shallow water will be there, and together they will cover 7.5% of the area. So 7.5% means what? All oceans, including all oceans part. So they, together, if you mix, so in that all oceans part means like 70.8% we have the water bodies. Okay. So in that water body, all those area if you cover, so totally 7.5% area is covered by the continental shelf. Okay, and average depth in this part, the continental shelf part, we have the 100 fathom. Remember that 100 fathom, and 1 fathom equal to 6 feet. 1 fathom equal to 6 feet. That means 600 feet. If we have that, if we go the nearby the sea area or near the water body, and if we have the all those land areas seen like up to the 600 feet, that means that is the part of continental shelf. And after if it comes, then there it will be coming all those continental slope and rise. So these are the continental shelves. So see, land submergence due to sea level rise, then sedimentation might also happen. Then coral reefs. So coral reef is what? When if they die, so that they'll be settling all those what you can say, all those skeletons of coral reefs. So they'll be like coming near the all those continental shelf boundary area. So because of that also we have the deposition. So because of deposition, there is the formation of continental shelf. Then that glaciated shelf will be there. Okay, means what? If that glaciation happens, if that melting of water happens, so there is the formation of that continental shelf area. So this is about the continental shelf. These are the major ocean relief features. Okay, so here you can see this is the part of continental shelf. Okay. Then here we have the continental break. This is the continental break, and then this part is the continental slope. Now after that, here in this part we have little bit sedimentation. This what deposition is there. So this part is the continental rise. Then after that, the abyssal plain starts. So these are the major relief features. So continental shelf, we saw all those parts. Okay, and in this also we have the Gulf formation also we have. So the shelf typically is at a very steep slope. That is known as the shelf break. So that we saw that continental break. That is known as the shelf break. So examples of continental shelves that are like Sunda Plate you can see, or when you go to a Grand Banks around the Newfoundland. So there you can see in the Australia and New Guinea, all those parts you can see is the continental shelf area. So there are various types of shelves. So all those names are given here. Glaciated shelf we have, that in the Greenland. Then coral reef shelf we have, that is Queensland. Then shelf of large rivers due to the deposition we have, that is the like Nile Delta you can see. There you can see. Then with the dendritic valleys. So in the Hudson River, there you can see that dendritic is what branch, that tree branch type that shelf is there. So there in the mouth of Hudson River you can see. Then with the young mountain ranges, there we have see Hawaiian Island. So there we have the continental shelf area. And formation all we saw all those parts. And width and depth is what? That width will be 70 to 80 kilometer, and the shelves are almost absent or very narrow along a convergent boundary. So they are almost absent or very narrow along the convergent boundary. Why? Because there is a formation of trench part. Okay. So when the convergence happens, means there will be the formation of trench part. So there, all those parts will be absent, continental shelf. But where if you see the divergence boundary, there we have the formation of shelf. So see in the continental shelf area, these parts are known as the photic zone. Means what? Here we have the sunlight reaching in the downwards path also. So here all those marine parts, plants. So all those marine plants that you can say that planktons. So that all those plants will be there in this place. And at this in the continental shelf area, from this place only we extract all those petroleum and natural gas. So this was all about the shelf. And importance of, we saw that we have the natural gas also coming from that part, petroleum also. Then from this part we have the importance, that is foods, and there are also sites of placer deposits. Then slope, that slope angle will be varying between 2 to 5 degrees. See in the in the slave part we saw about the 1 to 3 degree or less than 1 degree. Okay, and in the slope part we see here, it is that angle will be between, like it will be a steep type slope. That angle will be 2 to 5 degrees. The continental slope connects the continental shelf and the ocean basin, and the depth will be 200 and the 3000 meter, and there we have the 70 to 80 meter. So that wide continental shelf was wide up to like 70 to 80 kilometers, and here we have depth only up to, and in that depth we have like we can say at 60 meters. Okay, and here in depth we have 200 to 3000 meters. So in the slope part we have the depth this much. So that was about the slope part. Then after it we have that, because of deposition we have the continental rise. So the seaward edge of the continental slope loses gradients. So in that what will happen at this depth and give rise to continental rise. That means what? Deposition will be happening in this part. So because of deposition we have the continental rise. So continental slope boundary indicates the end of the continents. So canyons and trenches are observed in this continental slope part. Then continental rise, it will have an angle between 0.5 degree and 1 degree. Okay, so that is the continental rise. Okay, continental slope gradually loses its steepness with the depth. So as they go in the deep area, so there after slope what see here to this diagram also you can see shelf we have this part, then we have the slope area, then here we have the deposition at this part. So here we have the continental rise, and these are the abyssal plain, or you can say it as the deep sea plain. So deep sea plain, these are the flattest and smoothest regions of the world because of terrigenous. That means what? Marine sediments eroded from the land and shallow water sediments. that by the irregular topography. And that part and this part covers about 40% of the ocean floor. Okay, so continental, that deep sea plain or abyssal plain, you can say that it covers 40%, and the depth will be from 3000 to 6000 meters. So remember that also. And these plains will be covered in the clay and silt. Then that was about the major. Now in the minor, we saw about all those guyards, trenches, sea mounts, all those we saw. And also in that minor relief features, we have the atolls and coral reefs. So in this coral reefs, you can easily say that all those corals. So corals means what? When they will be dying. So because of deposition of their parts, coral reefs formation will be there. So now reefs and trenches. So that is the deepest part of the oceans. Okay, means what? There will be narrow depressions. So you see here, narrow depression type will be there. So that will be the deepest part. Their tectonic origin and are formed during ocean convergence and ocean continent convergence. So due to the ocean and also the ocean continent convergence. So here see this map and remember all those important trenches. See here in this part, here we have the North America, here we have the South America, this part, and then this side is Eurasia area. This is Russia, then we have the Japan area, then we have the China area, then it is coming to the like Indian Ocean, it is coming. Here we have the Indonesia. Okay, then we have the Australia area. So remember all these trenches. Just see the diagrams so that you can easily remember that at which place. See, these are all the parts of Pacific Ocean, and these are all the parts of Pacific Ring of Fire. Okay, so maximum trenches formation happens in these parts only. So remember some important names, like you can say here Puerto Rico Trench, that is in the this between North America and South America area. Then Peru Chile Trench, Tonga Trench. This part about the trenches part we'll see in the later parts also when we study about the oceans and sea. So there we'll see in that some parts. See in the Tonga Trench there is a deepest part. So there that also see. Then Mariana Trench, in this part we have the Challenger Deep, that is the deepest part. All those trenches just go through the map area so that you can easily recall all those where that particular trench is in the which area. There are some like 3 to 5 kilometers deeper. So these are all about the, and the trenches runs parallel to the bordering of the whole mountains. So these are the about the trenches. Then mid-oceanic ridges we saw, and you know that there is a mid-oceanic ridges in the Atlantic Ocean that is running for a length of 75,000 kilometers, and it has a height of 11. I think so. Yeah, it has a height of 11 kilometers. 11,000 meters is you can say. That means what? That Mauna Loa and Mauna Kea. So these are the parts of these parts. Then abyssal hills. So that you all saw about sea mount here. Sea mount. This means point tip type will be there. Okay. And if it has come up the water, then that is the island. Okay. And after the erosion, if the shape becomes flat shape, that is the guyards. So all these definitions are given. So flat top means what? That is the guyards. Then sea mounts and guyards are very common in the Pacific Oceans. Then canyons, so that deep gorge, that river flowing through it, so that is the canyons, and that is like a steep narrow. You can say it is similar like a trench part only, but canyons are near the land border area that is formed into the river area. Okay, so valley or low area between the hills or the mountain, typically the river or stream flowing through it. So that is the sea. Here in this diagram you can see valley, you can see here. Then gorge and canyons you can see in this part. So these are all about the submarine canyons. So there are deep valleys often extending from the mouth of the rivers to the abyssal plains. So they are the submarine canyons. So there are totally 3 types of submarine canyons. So that are small gorges which begin at the edge. So that continental shelf and extend down to the slope. So that is known as the oceanographer canyons. That is near the New England. So that you can see. So here that gorges you can say. So that is one more type canyons. Then we have the Indus canyons. So those which begin at the mouth of a river and extend over the shelf. So these are 3 different types of canyons. These are not that much important, but you must know that how canyon formation is happening and how does it looks like. And these three are not that much important. Then we have the dendritic valley. Dendritic valley. That means what? Like a branch, tree branch area. So those which have a dendritic appearance and are deeply cut into the edge of the cells and the slope, like the canyons of the coast of the southern California. That you can see the Hudson River. That Hudson Canyon, you can see there we have the dendritic valley. So that is about the dendritic valley, that is Hudson Canyon. Then see atoll, what is happening. These are low islands found in the tropical oceans consisting of coral reefs surrounding a central depression. So see in this part what is happening. See, we study about the lagoons formation. Okay. So similarly, it will be looking like a lagoons only. In this part, what will happen? See here. In this case, all those coral reefs, that formation will be there. Okay. And they will be forming like this part. And in this middle part, we have the, in the circle, we have the formation of like depression, you can say. And there is a one outlet part. So that type of formation is the atolls. And sometimes what happens, you can say that let all those deposited area, coral reefs, if they have died, so all those deposited area, that is known as the atoll. Okay. So that is the part of sea, or you can say it is a lagoon. So that is the lagoon in the sea area. And reef, it is a deposit made by a living or dead organism that forms a mound or rocky elevation like a reef. So reef means what? What is happening? That dead materials, that deposition is happening. So that is reef. And if that deposition happens in this case, suppose see here many reefs also will be there, and also some parts which dead parts will be looking like they will be enclosing. Like in this part they will be enclosing. So this part is known as the atoll. So by this seeing the diagram also you can easily guess. Okay. So just see the diagram and you can easily remember that like a lagoon formation if happens in the sea area, that is the atoll, and like a deposit, that is by dead organism or the living, and that will be like a mound area, that is the reef part. So the coral reefs are characteristic feature of the Pacific Ocean where they are associated with the sea mounds and bayous. So in this diagram, see here we have the continental shelf, then here we have the break, then here we have the continental slope coming area. Okay. Then again here we have the deposition. So here we have the continental rise. Then here starts the all those parts, and here we have the trenches, formation of trenches, and these are the parts of mid-oceanic ridges. And in this part, see here we have the island this part, then we have the sea mounds, then we have the sea mounds, then we have the bayous. So these are the different relief features of the oceans. So this was all about the different relief features of the oceans. So that's all for the different relief features of the ocean. And just when you go home, just go through all those slides and just give a study, just give a revision of the all those slides, because see by now you all that easily remember all those diagrams. Okay. So through the diagram also you can easily answer all those parts, and also remember the arrangement of all those continental rise, continental break, then you have the slope, continental shelf, then you have the break, then you have the slope, then you have the rise. So remember that order of that part, because that order has been asked. So remember that part. So that's all about the relief features. Tomorrow when you come to the class, we'll study about the tides. Tomorrow we'll study about the tides part, and also we'll see about the waves. So tomorrow we'll see about the tides and waves, and after it, if we have time, then we'll see about the oceans and seas, and then we'll see the other parts of like La Nina, El Nino, ocean currents. So all these parts we'll see, and we'll try to finish tomorrow. And after it, if some questions are left, then we'll try to have the extra class and we'll finish. Okay. And after tomorrow or day after tomorrow, your polity class will start, and also the history class will start. So if any doubt in these parts, just ask me on the WhatsApp. There I will reply to all those doubts. So that's all for today.